Hi everyone. In this video we're going to go over the Lab 3 calculations for the greener bromination of stilbene. So in this reaction we start with E-stilbene, and we'll talk about what that E means in a future lecture. It has to do with the double bond. And then after we add hydrobromic acid and hydrogen peroxide, we end up with dibromostilbene. And you can see the molecular formulas down below. In a previous video, I had the wrong molecular formulas, so these are the correct ones. C14H12 becomes C14H12Br2. Okay, so let's talk about the first calculation you have to do, which is percent yield. So this is problem 2A on your lab report. So remember from general chemistry, a percent yield is calculated by dividing the actual yield by the theoretical yield and multiplying that by 100. So your actual yield is how much product you have from your experiment. So if you're doing the lab online, the data is in a handout on the assignment page. If you did the lab in person, you would want to use the mass that you ended up with in lab. But to determine the theoretical yield, we have to do some calculations. So what we'll do to calculate the theoretical yield is start with the mass of stilbene that we started with. So if you're doing the lab online, that's 0.5 grams. If you're doing the lab in person, that will be whatever you weigh in lab. And we do need to convert that to the expected mass of our product, dibromostilbene. So we're going to determine theoretically how much product will form if everything goes 100% correctly, which in chemistry doesn't always happen. In fact, it very rarely happens. Now, unfortunately, we cannot directly convert the mass of the reactant to the mass of the product. We have to go through moles first. So we'll convert the mass of stilbene that we start with to moles of stilbene. And how do we convert from mass to moles? Molar mass. So you're going to calculate the molar mass of stilbene using the molecular formula C14H12. So once we have the moles of stilbene, then we can convert that to moles of dibromostilbene. And how can we convert from moles of reactant to moles of product? The molar ratios. Or another way to put that is the coefficients in your chemical equation. So if we go back to our chemical equation, what is the ratio between stilbene and dibromostilbene? 1 to 1. So that's super easy. So however many moles of stilbene we have will equal the moles of dibromostilbene that we expect to form. So now in the last step, we're going to convert moles of dibromostilbene to a mass. So how do we do that? Using molar mass. So we'll calculate the molar mass of dibromostilbene. So we can do that using the molecular formula for dibromostilbene, which is C14H12Br2. Okay, so just a little bit of Gen Chem review for you. Okay, so now let's go to the next calculation in your lab report. So the next calculation is the theoretical atom economy. So this is number 2B. So I'll just abbreviate this TAE. So our theoretical atom economy is equal to the molecular weight or molar mass of the desired product. So for us, that's dibromostilbene over the sum, so that Greek symbol means sum, of the molecular weight of the reagents. So if we go back to our reaction, our reagents are stilbene, hydrobromic acid, and hydrogen peroxide. So we're going to calculate the molar mass of stilbene, but we already did that in our previous calculation. So now we just have to figure out the mass of HBr and the mass of H2O2. So let's just write here, we're going to use the mass of E-stilbene, HBr, and H2O2 and add them all together. All right, so that's not too bad. So now the next calculation is the experimental atom economy. All right, so this is problem 2C on your lab report. So I'm just going to abbreviate this again as EAE. So the experimental atom economy is equal to the theoretical yield in grams, which you already calculated for the percent yield. So you just plug that in. And then we're going to divide that by the total mass of reactants used. And that will also be in grams. Now, you might be wondering, wait, I had a volume of HBr and a volume of H2O2. How do I get that into mass? So if we want to convert volume to mass, what can we use as a conversion factor? Density. All right, so we need the mass of stilbene plus the mass of HBr that we used plus the mass of H2O2. So the mass of stilbene will be 0.5 grams if you're doing the lab online. If you did the lab in person, that will be whatever you weighed out in person. Then the mass of HBr, we said that we used, let's see, a volume. So it should be around 1.2 milliliters of HBr. And again, we can convert the volume to, oops, I meant to write mass. We can convert the volume to mass by multiplying it by the density. So you'll have to look up the density of HBr in order to do that calculation. And then for hydrogen peroxide, H2O2, we used 0.8 milliliters. So we would do the same thing there. We would convert the volume to mass by multiplying the volume by the density of H2O2. Now remember, we used 30% hydrogen peroxide. So make sure to look up the density of 30% hydrogen peroxide. Okay, so those are all of the calculations that you'll do for the lab. And if you have any questions, make sure to message me or email me or set up an office hour. Good luck!